really like about the building is the way that light has been used from all around the building.
I think it's a magnificent building for the children, and it's an asset for the whole area.
To be able to construct a building that would be used by young adults to learn mathematics and science in an inspiring environment was particularly satisfying. Our brief was to provide a building that contained specific criteria. We needed dynamic floor loadings and we needed to take account of thermal mass. Our conclusion was that the best solution is to use structural steelwork coupled with precast concrete floors.
Steel is recyclable, steel is light, therefore it contributes that way to the small carbon footprint of a construction. It's not the frame that contributes most to the thermal capacity of the building, but it's more the exposed floor slabs. And steel here facilitated the use of precast floor slabs and bought us a lot of time and saved design costs as well and on-site labor. The site suffered from a lot of constraints, including height constraints due to the neighboring terraces on the east side. Most of the site was taken up by a public car park, which had to stay operational during the construction and beyond. Took the risky step of raising the sports hall, which is a significant part of the building volume, above the public car park, whilst maintaining traffic and the route through and visual connections underneath, through to the sports fields beyond. The long span of the sports hall itself is resting on two-story high columns. Steel was the most sensible choice.
Within the teaching blocks we used ASB beams with a wider bottom flange to support the planks. This allowed the mechanical services to be distributed around the building a lot easier without cutting holes in the steels or altering the concrete planks. It is a sustainable building, it's a very efficient building to run, it's a very efficient building to maintain as well. From a steel frame perspective, I mean, there's interesting features all the way around the building. We have the projecting boxes on a couple of elevations at different levels. We supported the viewing gallery with a series of hangers from the level above. We ended up with 330mm rods supporting the whole structure in that area, which was quite an achievement.
We found that we were inspired by Newtonian principles such as levity and gravity and optical discoveries that I believe gave us the opportunity to create a timeless architecture that works with the educational ethos of the school. On the facades of the sports hall, a series of vertical fins reveal Newton's rings from different viewpoints. It always appears somewhat different.
There's a number of things that make me feel proud. One of the things is delivering the project on time with the steel frame that we used. Another thing which was quite innovative was we've developed a whole BIM model for this building using the steel structure and the steel frame. So we collaborated really well with the fabricator by transferring our model to the steel fabricator as well. And that went quite seamlessly.
We managed to create a building that is more than just a school.
The project has received wide acclaim for its exemplary environmental performance. I think it's a credit to Redbridge and Arc schools that they've allowed the team to build and develop a project that will allow children to learn and work in a school that will be used by many thousands of children for years to come.